Hello there and welcome to Earth with Nature, your quiet sanctuary for exploring the wonders of our planet and beyond, where we invite you to slow down, breathe deeply, and let curiosity guide you through the timeless stories etched into the very rocks beneath our feet. Tonight, we're embarking on a gentle voyage back through the eons, leaving behind the familiar outlines of today's world to immerse ourselves in the ancient majesty of Pangea, a colossal supercontinent that once unified nearly all of Earth's land masses into one vast, unbroken expanse. Imagine, if you will, standing on a landscape where continents we now know as separate entities were fused together, with no Atlantic Ocean to divide the Americas from Europe and Africa, and no Pacific to carve vast separations. Instead, one could wander from what is now North America straight into Asia, then southward into Africa and South America, all on foot, across endless horizons of land ringed by a single, encircling ocean called Mantle. As we settle into this contemplative journey, take a moment to reflect. What would it feel like to breathe the air of a world without modern boundaries, where the sky stretched infinitely over a unified Earth, and the ground beneath you pulsed with the restless energies of tectonic forces? On Earth with Nature, we delve into these planetary science facts with a sense of cosmic wonder, drawing from geology and paleontology to paint vivid pictures of this lost era hundreds of millions of years ago, during the late Paleozoic and into the Mesozoic, when powerful plate tectonics slowly welded together ancient land masses like Laurussia, the precursor to North America and parts of Europe, and Gondwana, encompassing future South America, Africa, Antarctica, Australia, and India, through cycles of supercontinent formation that geologists call the supercontinent cycle, much like how modern technology in satellite imaging and seismic monitoring helps us trace these ancient seams today. Picture the dramatic collisions, as plates converged at rates of mere centimeters per year. Oceans like the Reich shrank and vanished, crumpling the crust into towering mountain ranges such as the Appalachians and the Atlas, relics we can still hike today, forged in fiery volcanic upheavals and immense pressures that released magma and ash into the skies, reshaping climates and birthing vast river systems that carved valleys and nourished wetlands. In this immense interior, far from oceanic moisture, arid deserts sprawl for thousands of kilometers, with red sandstone beds, iron-rich sediments preserved in rock layers, bearing witness to scorching summers and frigid winters, while coastal edges bloomed with humid forests of seed ferns and towering conifers, teeming with life adapted to high oxygen levels that allowed dragonflies with meter-wide wings and early reptiles hinting at mammalian ancestors to thrive. Pause here and wonder, how might such isolation and connectivity have sparked evolutionary innovations, mixing species across boundless terrains without barriers, setting the stage for dinosaurs and beyond? These exoplanet mysteries aren't just about distant worlds, they echo in our own planetary science facts, reminding us of Earth's fragility and habitability, as Pangea's unified form influenced global winds, sweeping dust from inland deserts to nourish distant ecosystems, and ocean currents in Mantle, redistributing heat in ways that swung between ice ages and tropical monsoons, all while an inland sea like the Paleotethys harbored thriving reefs. Through thoughtful reflection, we see how this ancient unity, born from relentless geological forces, left indelible marks on life's evolution, fostering a sense of awe at our planet's dynamic history, much like how today's advancements in deep-sea drilling and fossil analysis uncover these stories, inviting us to appreciate the wonder of an earth that gathers and scatters its lands in eternal rhythm. As we linger in this immersive tale, let the imagery of Pangea's vast, undivided landscapes evoke a peaceful sense of connection to the cosmos, or our world is but one chapter in the grand narrative of planetary transformations. Building on that profound sense of unity, let's transition deeper into the heart of Pangea's story on Earth with nature, where we celebrate the philosophical reflections on our planet's habitability and the fragile beauty of its ever-changing face, encouraging you to envision yourself wandering those ancient plains under a sky unbroken by modern divisions, feeling the ground tremble subtly with the same tectonic whispers that modern GPS technology now measures with pinpoint accuracy. As Pangea reached its zenith around 250 million years ago, spanning from pole to pole and straddling the equator, it created a tapestry of extreme climates that tested life's resilience. Equatorial rainforests dense with primitive trees forming the coal deposits we mine today, contrasting with polar ice sheets scratching glacial marks into rocks that paleontologists study to reconstruct this era's swings between warmth and cold, all influenced by the supercontinent's massive scale that blocked moisture inland, birthing megadeserts where seasonal monsoons occasionally brought life-giving rains, carried by uninterrupted wind patterns far more intense than today's fragmented systems. Reflect for a moment, in a world without oceanic barriers, how did animals roam freely, spreading from Asia-like regions into what would become Europe? Their fossils now found mirrored across continents as evidence of this connectivity, sparking evolutionary bursts that led to the rise of dinosaurs in the Triassic, with early mammals scurrying in the undergrowth and insects evolving gigantism in oxygen-rich air. This cosmic wonder ties into broader planetary science facts, much like how astronomers today discover exoplanet mysteries with telescopes like Kepler and James Webb, revealing worlds with potential supercontinents of their own, prompting us to ponder Earth's uniqueness amid the universe's vast array of habitable possibilities, where fragility meets resilience in the dance of plates that not only built Pangea through collisions but also sowed the seeds of its eventual breakup. As Mantle, Convection began pulling it apart, opening rifts that would form the Atlantic and scatter lands anew. Vividly imagine the volcanoes erupting along suture zones, painting skies with ash that fertilized soils, or rivers winding endlessly without seas to halt them, supporting ecosystems where amphibians transition to reptiles in swampy basins, all while the surrounding Panthalassa Ocean harbored marine life in its depths, its currents a global thermostat far simpler than our modern ones. Through these engaging facts from science and technology, such as computer models simulating ancient climates, we build emotional investment in the wonder of it all, seeing Pangea not as a static relic but a living chapter in Earth's story, reminding us of our planet's impermanence and the philosophical depth of viewing it as one of many worlds, potentially echoed in distant exoplanets where similar geological symphonies play out. As we continue to walk the ancient trails of Pangea, let us turn our gaze beneath the surface, into the slow churning of Earth's mantle where the very idea of continents was born. Deep within this semi-solid layer, heat from the planet's interior fuels convection currents, massive, swirling movements of rock that rise where it's hot and sink where it's cooler. These currents act like invisible hands, shaping the fate of continents over millions of years. Through this ceaseless motion, lithospheric plates are drawn together or torn apart, their collisions welding new terrains or birthing fresh ocean basins. In Pangea's case, the convergence of plates led to massive Orogenies mountain-building episodes so vast they stitched together entire regions. The Central Pangean Mountains, for instance, stretching across what is now eastern North America and northwestern Africa, are not merely local features. They span thousands of kilometers, their peaks rivaling the Himalayas in height. These ranges formed as Gondwana collided with Laurussia, a tectonic embrace that crumpled the crust and metamorphosed rocks under crushing pressure. And as these mountains rose, they altered wind patterns, trapped moisture, and carved rain shadows, influencing ecosystems far beyond their slopes. In the lee of these ranges, vast basins formed, places like the Newark Supergroup in present-day eastern U.S., where sediments accumulated in great thicknesses. These basins recorded every shift in climate, every volcanic pulse, every tremor of the earth as it stretched and cracked. Some of these cracks, embryonic rift valleys, were the very first signs of Pangea's eventual breakup. As molten rock welled up and intruded into the crust, it left behind dikes and sills, igneous fingerprints of a planet preparing once again for transformation. And within these basins, life flourished in surprising forms. The Triassic Period saw an explosion of adaptive experimentation. The earliest dinosaurs, still small and fleet-footed, shared their world with mammal-like reptiles, Therapsids, whose lineage would one day give rise to us. Crocodilian ancestors stalked the waterways, and early pterosaurs took to the skies, their wings stretched taut over elongated fingers. The diversity of these faunas wasn't confined to a single region. Because Pangea lacked the geographic barriers we see today, these species could migrate far and wide, their fossils now scattered across continents that today lie oceans apart. This mobility also applied to flora. Glossopteris, a sea fern with tongue-shaped leaves, spread across the southern supercontinent Gondwana. Its remains now found in South America, Africa, Antarctica, India, and Australia. Its presence in such distant lands puzzled early geologists and was one of the key pieces of evidence in support of continental drift, long before plate tectonics became accepted science. These hardy plants formed dense forests along riverbanks and wetlands, laying down the organic material that, over time and under pressure, became the coal seams of today, a deep-time legacy still powering human civilization. Yet, even as life diversified, it was not immune to the planet's shifting rhythms. Around 252 million years ago, at the close of the Permian period, Earth experienced its most severe mass extinction, the Permian-Triassic extinction event. Over 90% of marine species and 70% of terrestrial vertebrates vanished. The causes were complex. Massive volcanic eruptions in what is now Siberia released vast quantities of greenhouse gases, triggering runaway climate change, ocean acidification, and anoxia. These eruptions were part of the Siberian Traps, one of the largest volcanic provinces in Earth's history, covering over 7 million square kilometers with lava and ash. The effects were catastrophic. Oceans, once teeming with trilobites, crinoids, and brachiopods, fell silent. Coral reefs collapsed. On land, forests withered under intense heat and drought, and ecosystems unraveled. Pangea's size only worsened the crisis. Its interior was already dry and prone to temperature extremes, and the climatic disruption turned these arid zones into inhospitable wastelands. But from ruin came renewal. The survivors of the extinction found themselves in a world of open ecological niches. The Triassic became a time of evolutionary experimentation. Insects diversified rapidly, flowering plants had yet to evolve, and gymnosperms like cycads and conifers dominated the landscape. Early archosaurs, ancestors of crocodiles, birds, and dinosaurs, rose to prominence. The climate remained generally warm, lacking polar ice caps, and monsoonal patterns driven by the supercontinent's vast scale shaped the weather for millions of years. As Pangea drifted towards its inevitable fragmentation, the tectonic plates began to rift apart. This process began subtly during the late Triassic, but by the Jurassic, true oceanic crust was forming in what would become the Atlantic Ocean. Magma surged upward along these rifting zones, creating new seafloor and pushing the continents apart. North America began to separate from Africa and Europe. South America slowly pulled away from Africa, leaving behind matching coastlines and geological formations, one of the most compelling pieces of evidence for continental drift. Along these rift zones, volcanic activity flourished. The Central Atlantic Magmatic Province, CAMP, became one of the largest flood basalt events in history, covering over 10 million square kilometers with lava. Its eruptions released tremendous amounts of carbon dioxide, potentially contributing to another extinction event at the end of the Triassic. Yet, life proved resilient. The Jurassic period heralded the age of dinosaurs in full bloom. Sauropods thundered across fern-filled plains, theropods hunted in packs, and pterosaurs soared over lagoons shimmering under a greenhouse sky. In the seas, ammonites and marine reptiles like ichthyosaurs and plesiosaurs ruled. Coral reefs began to recover, forming vibrant habitats in shallow waters. As the Atlantic widened, Panthalassa, the once encircling global ocean, began to give way to new ocean basins. The Tethys Sea, nestled between the northern and southern landmasses, became a vital corridor for marine life, its sediments preserving exquisite fossils that now grace museum halls. Meanwhile, high in the sky, the Earth's atmosphere continued to evolve. Oxygen levels, which had peaked during the Carboniferous, fluctuated with global temperatures and biomass. These variations influenced the size and metabolism of animals. During times of high oxygen, arthropods grew to massive sizes, dragonflies with wingspans over 2 feet, millipede-like creatures stretching meters long. These organisms thrived in swampy lowlands where decaying vegetation created oxygen-rich microclimates. As we reflect on Pangea's story, we see not just a geological configuration, but a crucible of life, change, and connection. Its formation and breakup shaped the very pathways of evolution, determined the flow of oceans and winds, and left fingerprints in every corner of our modern world. Folded mountain chains, fossil distributions, matching rock strata, and paleoclimatic indicators all whisper of a time when Earth was one,